Good evening, class. I want to specially welcome you to our Python class tonight. Okay. Good evening, class. I want to welcome you to our class tonight. In the last class, we talked about the Python constants. We talked about the Python constants, and also we talked about the data types. The Python constants and the data types. That was what we talked about the last time, and we were able to look at the constants, and basically we talked about the user-defined constants, and also we looked at the inbuilt constants. And I made mention towards, I told us last time that the inbuilt constants are the constants that comes along with your Python program, and in the course of your installation you have your inbuilt constants, installed into your system, and while you're writing your code, you are able to use them as you call for them by importing them into your program. Yes. So that was what we talked about the last time. Like I said, the constants, inbuilt constants, and the user-defined constant. And also I went ahead to talk about the data types. Yes, and we mentioned a few of the data types. We mentioned the last time I was able to talk about the integers. I was able to talk about the floating point numbers, the complex numbers. We discussed a lot about the lists. We're also going to, by extension, say one or two things also as regards the list. And also we talked about the tuple last week, and this evening we're going to continue. We're going to go back a little bit. I'm going to be looking at a few things tonight. I'm going to look at the Python arithmetic operators this evening. You need to understand that because it's very, very important. The features of the Python arithmetic operators are very, very important, so you need to actually get handy with that. So I'm going to talk about the operators, various operators in use in your Python program. And also I'm going to talk about list comprehension. And in discussing list comprehension, we're going to look at how to look through our lists. And let's not forget that our list is one of the data types we have, and we're going to look at how we can actually look through our list in various ways. And then we're going to, this evening, we're going to see how to carry out one or two exercises. Yes. So as time permits us, I hope we should be able to achieve that. Okay? Once again, good evening and welcome. Yes. So Dorothy, good evening and welcome. I believe you can hear me. So I'll just go ahead immediately. I will start with the arithmetic operators in Python. Now, when I mean arithmetic operators, I'm simply talking about I will relate it back to what we know. Operators in this slides, okay? Operators in this slides actually talks about the various, just like you can relate it back to your mathematics. I can say the operators in this case are the various mathematical operators in use. Like you have your addition sign, your multiplication sign, your division sign, exponential sign, and the rest of them. We also do have the same in our Python program because it helps us to do our calculation, write our calculation, and the codes actually that follows. Dorothy, you're welcome. All right. So now, this evening we're going to look at, I'm just going to make a list of all the Python arithmetic operators and then show you the symbols. Okay, the symbols we normally use to carry out calculations as we apply these operators. The first, let me just write down there. The topic we're looking at this evening is Python arithmetic operators. Okay, operators. So that's what we're looking at tonight. And the operators we're going to be looking at are, we're going to look at the first one there. The first operator is the addition operator. Okay, addition operator. Addition operator is represented with the symbol, the plus symbol. Okay, the plus symbol, and this is similar to what we have in our mathematics. And then also, apart from that, we have the subtraction operator. Subtraction operator. Subtraction operator. Okay, so this is represented by, okay, so this is, so subtraction operator is represented by the normal minus sign that we know, subtraction sign that we know. Okay, so and then we have also a multiplication operator. We also have a multiplication operator. Multiplication operator, and this is represented by the asterisk sign, the asterisk sign. So this is different from what we have in the general mathematics. In this case, we are using asterisk instead of using the normal, usual, common multiplication sign that you and I are used to. And also we have the division sign operator. We have the division sign operator, division operator. Okay, the division operator is represented by a forward slash sign, Okay, so each time you want to divide, that's what you use. Okay, so we also have the exponential operator. Exponential operator. Okay, this is represented by double asterisk sign. That's our exponential operator. So, and when I mean exponential, I mean you want to raise a number to a power. Okay, you want to raise a number to a power, that is exponent. So you can say raise to the power of, so you can use double asterisk to do that. Okay, so now we also have a modulus operator. Modulus operator is represented by the percentage sign, with the percentage sign. Good. So the modulus operator is simply what we call the remainder operator. It tells you the remainder after carrying out a division operation. So the remainder of that is what we call the modulus. Okay, maybe you divided 5 by 2. 5 divided by 2 will give you 2 remainder 1. So the one you're seeing there is the modulus, or you call it the remainder. Okay, so apart from this, we have the assignment operator. We have the assignment operator. This we've been using this regularly, the assignment operator. Okay, assignment operator. Assignment operator is simply our equality sign. So this is the assignment operator, our equality sign. Since I'm introducing that to avoid confusion, I'm going to use a column to introduce that. So it's the equality sign. The equality sign is the assignment operator. So in mathematics it is called equality sign, but here in Python program it is not equality sign. We call it assignment operator. But then we have the equality sign. Okay, equality sign. Okay, equality operator, right? Okay, it's now I'm still using my column to introduce this because we're using the equality sign. So double equality sign. As I assume in mathematics, this should be a double equality sign, but in Python program this is equality sign. So anytime you want to say something is equals to, this is what you actually use to symbolize equality. Good. So apart from this, we have the inequality signs we normally use in mathematics. We have the greater than operator. We have the greater than operator. Okay. So that is this. Then we have the less than operator. Operator. Okay. So that will be the other way. Okay, these are the few operators that we have in Python program. These are the few operators we have in Python program, and we are going to be using this. We're going to be applying these operators as we proceed in our programming journey. We're going to be using this regularly, all these operators. This first instance, it may appear a little bit cumbersome or a little bit confusing to you, but as you continue in your programming journey, definitely you should be able to, everything should get easier as you continue with your journey. So for now, what is very important is that you need to go through them and understand that these are the application of these operators in these various lights and in these various terms. Yes. So for instance, if you want to apply any of this, you can apply. For instance, you can say you have your z to be equals to 6. Okay, and you have your y to be equals to 12. Right, so I can easily say okay, calculate will be equals to, I want to use the division sign. I can easily say y, okay, divided by y divided by z. Y divided by z, that's what I'm having there. Then I can just go ahead to print this. Print my y divided by z. I'll print my cal, please, because I'm printing the variable like I told us. Cal equals to y divided by z is actually an assignment statement. So y divided by z has been assigned to the variable cal. So I'm printing my variable. I told you in the last time we talked about variable, I said the variable is actually a store of value. So the value of y all over z is stored in cal. And then you can see that in this case we are also dividing two variables, because y is a variable, z is also a variable, and these are store values. They are both store values because y has a value store. Okay, now you can see y, you can see the description from the pie chart. You can see that y has a value store of 12. Okay, y has a value store of 12, and also z also, if I wave my cursor over z, okay, but z also has a value store of 6. A value store of 6. So that is what we have there. So if I go ahead to print this, I should have all I need. Okay, I should have 2.0. Okay, 2.0 have been printed out, and the 2.0 is actually I actually divided. So the very simple importance of this illustration is that I have been able to use my / sign, which represented my division sign, okay, to illustrate to us that this sign actually means divide. Okay, so I can also change this to multiplication by introducing an asterisk. Okay, I told us that in PyCharm here, the asterisk is the multiplication sign. So y times z, I'll still go ahead and print. It should give me 12 times 6. Okay, 12 times 6, 72. So you can see we have been able to use that to illustrate. Yes. Dorothy, are you following? Hello?
Yes, sir. Yes, sir.
You're welcome. Okay. So
Thank
now,
you, sir. Good evening.
good evening, yes. Alright, so now we have used the division sign and multiplication sign. We can also use the addition sign to clearly illustrate to us that these are the symbols in use in our loives. It is recognized. Whatever is not recognized in loives will not be printed. It will not be executed. So I'm changing that to my positive figure number, and it's giving me 18. That means it is recognized. Okay, it is recognized. So also we talked about the we talked about the raised to the power, that is the exponential operator, and I said the exponential, for instance, I can write W, for instance, equals to, or I can write okay, let me just say print. So I'll just go ahead and print again. I'll say print. Let me make reference from what I have there. Print in brackets. Okay, print in brackets. Then I'll write 6. I'll write Z, since I have Z. 6 is a store value, a value stored into Z. So Z. Then I'll just have a double asterisk there. 2. Okay, let me print that and see what the outcome will be. Okay, so I'm having that to be 36. So it simply means 6 raised to the power of 2. So we say double asterisk simply means exponential. Exponential. So you need to get used to all this, please. It's very important you get used to all this. So you can apply this. You need to go through this, go over them over and over again, and then in the course of our programming we are going to be using them. So I believe as we keep using them, you get used to all this. Yes, so we have actually mentioned, we've listed all the Python arithmetic operators, the addition operator, subtraction, and the rest of them. So quickly, I wanted to go back a little bit to our Python list. We needed to do some operation. Okay, we needed to do some operations on our Python list. We have actually considered few of the things we can do with our Python list, but there are still more, and we don't want to leave any stone unturned. So I want us to still go through. So I will still go back again. This evening I want to look at what we call the list comprehension. List comprehension in Python. List comprehension, that's what I want to look at this evening. The list comprehension. So the list comprehension. But before I go on, I will call your mind back to our explanation of a list, of a Python list. And I said a list is actually an enclosure or a set of items enclosed in a square bracket. Okay, a set of items enclosed in a square bracket is the list. For instance, you say items equals to square bracket, like I said. Then you have, for instance, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a very good example of a list. So there are some features I wanted to bring out here. So now, a major feature number 1. Initially, we talked about how to access items from our list. We talked about how to print, and I told us that I explained that lists, in a list we have what we call exponents or powers in a list, meaning that every single item is assigned a power or an exponent, and it goes the positive exponent goes from the left side, your left side, towards the right. And I said like the first item you have here, 1, has a positive exponent of 0. Okay, 0 is assigned to 1, and the 2 here has 1 assignment, power 1 assigned, then power 2, 3, 4, 5, 6, 7, and 8. So that was what I explained. So I said it has an index assignment. Okay, so also I said from the right side to the left side, we also have a negative index assignment. For instance, the 9 we have here, we have a -1 assignment to 9. Then coming to the next 8 here, towards your left you have a -2. 7 towards your left you have a -3, -4, -5, -6, -7, and so on. Okay, so I clearly explained that before. So one thing I want to talk about, the use of a particular function called len, L-E-N. Okay, L-E-N, len. Okay, good. You can call it the length somehow, but the len actually tells you, okay, the len gives us a description of the number of items in a list. Okay, so the len gives us a description of the number of items in a list. So I have this list now. Okay, I have this list now. All right, now I can say find equals to len, okay, in brackets I'll put my item inside, items. I'm simply asking, I'm using this now, is a keyword in Python. I told you there are so many keywords we have in Python, and I told us that keyword are reserved words in Python, and they have special functions. So we're picking them up one after the other. In this case, now today we just came across this len, and I have given a brief description. The len actually tells you, gives you a description of the number of items in a list. So now I said find len in brackets items. I'm simply asking, using this to find the number, to count. I want this to count the number of items in a list. So if I print find, okay, I print my find, it should give me the number of items in that list. Okay, so now you can see my outcome is telling me that we have 9 items in this list, 9 items. So now we can now go through the stress of counting. Since the list, our list is not too much, so let's just go through the stress of counting this. Now we're just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 items in a list. Okay, so we were able to use this to actually figure out the number of items in this list, items. Okay, so the len keyword is very useful in so many operations in Python program. In so many operations, it's very, very useful. For instance, I may want to find the average of numbers. Okay, I may want to find the average of numbers in this list. Okay, now I can say find, I can say sum. Okay, sum is a keyword. Okay, sum of items divided by the len of items. Okay, sum of items divided by the length of item. And what it simply means is I'm expecting the list to sum up all the items in that list divided by the number of items. And you know that the sum of items divided by the number of items is going to give you the average. So let me quickly change this, because it's like I told us when we were talking of identifiers and keywords, we said identifiers are names given to functions, to variables, to most of the operations we carry out in Python programs. So in this case, and we said identifier must be able to tell us something about that program. So sum divided by the total number of items is actually talking about the average. So I will use an identifier that relates to the average. So I'm going to use AVR. Okay, AVR, short for average. This is what I want. So then in this bracket prints parentheses, I'm still going to use my AVR. Okay, so I have that now. So I'll just go ahead and print this. Good. So it's telling me now that the average of the numbers in this list is 5.0. 5.0. So if you do this manually and you decide to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, whatever it gives you, you keep it aside, then you count the numbers 1, 2, 3 and the rest, it gives you 9. That's summation of the first number divided by your total number, which is 9, will definitely give you your average, and your average is 5.0. So you can see the importance of the keywords we are bringing up. We have seen the len keyword, and there's another keyword we just brought up here, sum keyword. So the sum is actually popular, and the sum is used to add up every item on the list. Okay, all the items on the list, the sum is used to add them up. Okay, I want to believe we are together and we're following. All right, so good. So now in this list, like I said, we are looking at the list comprehension. We're going to be talking about a few things. I think we have already looked at a few of them. We have looked at the len, and with the explanation given, I want to believe it has been clearly kind of expatiated, and it has been expatiated in a way that I want to believe it's clearly understood by everyone by now. So the len, like I said, the len keyword gives you the number of items on the list, and the sum gives you just the summation of the items. And the item I'm putting here, sum, and then in parentheses item, makes reference to the name of my list. The item here is not it's not a keyword, it's just an identifier or a variable name. I can decide to change it to anything, and you also can decide to change yours to anything. So you can make your code to be as unique as you want it. Or in this case, this is what we have decided to choose as an identifier. So there is no strict rule. It's not a must that it has to be items. No, you can have something else there, and it doesn't affect anything. Okay, you can have none or numbers. Okay, you can have numbers. Right, so it's still okay. But once you have that, you have to come here and effect the change you've made, so that your program will be, there will be a clear coherence. So we are effecting the new identifier. So with that, now we can still go ahead and run our program, and we have the same outcome. So there is no difference, it's still the same. So you can choose any suitable name for your identifier. Okay, good. So now we have talked about the len, and also we have talked about the average. Okay, we have talked about the average. Now we're going to look at how we can actually fetch out the odd numbers on a list. Okay, so I'm going to, on this list, or let's see how we can design just do a very simple exercise this evening. Okay, a very simple exercise. We're going to write a very simple code. I think this should be like our first code in this class, first major code or major exercise in this class. So we want to write a code, a simple Python program. Want to write, okay, sorry, this is supposed to be an hash. Okay, want to write a simple Python program, okay, to check even and odd numbers, Okay, now, so that's just it. So now, like I said, you have your lists. For instance, you can have your list numbers equals to square brackets, then you have 2, 3, 4, 5, 6, 7, 8, 9. So this is your list. Or in the case of this list contains items inside them. But the question now is this: what if we don't have items in the list? Okay, You can still have another list, call it number 1. Then you have this. So this is an empty list. This is actually an empty list. Okay, so this is you call this an empty list. So there are no items, there is no item in this list. Good. So now in another case, you may want to take input from your users. Maybe you have designed a program and you want your user to enter some inputs for you to be able to do some calculations. So this is leading us to the very simple exercise we want to do. This takes us to what we call the impute statement. You can actually take an impute statement. In this case, we did our impute ourselves to give some illustration, but the convention is that you can take an input from users. Okay, so you can say INP equals to, so you say INPUT, that's your input. Okay, your input, then in quotes you can say enter a number, enter a number. Okay, then you have a column there. So with the input, we're using another keyword here, input. So each time this keyword comes up, automatically Python understands and recognizes that you are not the one feeding in the input. Now in this case, we are the one that supplied this. I have number and I supplied all the numbers. In this case, it's just an empty list. But in this case, I don't want to supply the number myself. I want somebody else, maybe somebody who uses this, to supply the number. So I'm going to use what we call the inputs. Like you go to your ATM machine and you want to make withdrawals. What happens? Most times they'll ask you, okay, enter your PIN. It's a very simple example of input. The ATM machine has been programmed and an impute statement has been used, and it's asking you, please enter your ATM PIN. Okay, please, what denomination do you want, what bank do you want, enter, and you are the one entering all the all the figures and all the values. Same thing applies here as well. So now the first input, INP, equals the inputs in parentheses, enter a number. Okay, now I'm going to go ahead and introduce something. I can say okay, I can say if INP, that's the inputs, if INP, okay, if INP is, I'll use my dollar sign, sorry, my percentage sign. If INP divide by 2 equals to 0. Okay, if this is equals to 0, then I can say print, then I will give it whatsoever expression I want. I can say print this number, is an even number. Don't worry, I'm going to explain all this process. I'm going to go by it slowly and then bit by bit to explain this. Okay, so now I'll say else, meaning if it is not, if INP divided by 2 is not equals to 0, okay, else, that's the meaning of else, then I'm going to print this number is an odd number. Okay, good. So now let me explain this process. I said inputs, we're taking user input here. Okay, now I wanted my user to impute a number. Okay, now I'm going to decide, this program is meant to calculate or to tell us if the number that was imputed here is an even number or an odd number. Okay, and we know that for even numbers, when even numbers are divided by 2, okay, there is no remainder. That means it is 0. There's no remainder. But if you divide a number by 2 and it gives you a remainder, that means that number is an odd number. So that's why I say if INP is here, okay, and INP is a variable we have introduced representing the number your users are entering, okay, the input your users are making. Okay, so I told you that a variable is a store of value. So at this stage, or at this point in our programming journey, I think you should be getting your mind ready as a programmer. So now we're not just entering just 1 or 2 figures. Now we're trying to do something we're trying to advance a little bit. So now we say input in parentheses, then you just say enter a number, and the enter a number is my own design for this. You can just write anything, or you can present it in a way but still saying the same thing. Okay, you can say please enter a number, but in my own case I said enter a number. Okay, so there's going to be a prompt if I run this program. Now I now come down here and use my if statement. I think I talked about the if conditional statement, and the condition I'm giving here that if INP, okay, percentage sign, meaning divided by 2, this is the modulus sign. Okay, if INP divided by 2 is equals to 0, then I'm going to print, I expect my Python to print this number is an even number. Okay, or I say this is, let me take this out, this is an even number. Okay, now I will also say this is, I'm just trying to modify my output. Okay, this is an odd number. Okay, so I will just, let me go ahead and run this program and see what happens. Okay, now I just ran the program. You see what is happening. Enter a number. I'm having a prompt here, enter a number. So this is an impute statement. I'll go ahead and enter a number. I'll enter an even number and see what happens. I just entered my 10. Then I'll hit my enter button. Okay, I'm having an error, so let me see what happens. They said if this INP, not all argument converted during string formatting. So it's simply telling me that I need to convert this, and what it means is that the number entered is not seen as a number, it's seen as a string. Okay, so I need to go ahead to do a conversion, and to do that conversion I'm going to write an int at the back of my impute statement. Then I'll wrap it up in the brackets. I'll wrap that up in the brackets. Okay, then I'll run my program again and see what happens. It said enter a number. I'm going to enter 10 again and hit my enter button. So I have my output. It said this is an even number. Okay, that means our program is correct. This is an even number. Okay, I enter 10 and 10 is an even number. Now I'm going to enter another number, maybe an odd number now, 19. Let me just enter 19 and see what happens. So I run this program again. It says enter a number. I'm going to enter 19. I say this is an odd number. This is an odd number. Okay, so we've been able to actually print out our even number and also our odd number. So this very simple program here can actually tell us, okay, like we said, to write a simple Python program to check, okay, to check even and odd numbers. Okay, so this is a very simple program, and this can actually tell you all even numbers in the world as you're entering them. So whatever number you're entering, it will tell you enter a number. You just go ahead and maybe 33. Okay, 33. Tell you that this is an odd number. Okay, if you just click again and say enter a number, and you say you're entering 88, it will tell you that 88 is an even number. Good. So it's just a very simple code, and with this you can actually tell, this program can help you to check if what you're doing is an even or an odd number. Good. So now we're going to look at iteration. Okay, we're going to look at iteration briefly, and when I mean iteration, I'm talking about loop. And I told us we're going to go over a few things on the Python list. Okay, more about the Python list. We're going to look at iteration. Okay, so Python iteration. Okay, Python iteration, that's what we're going to look at now. And I told us iteration simply means looping. Okay, iteration is a way of looping through a list of numbers or items. Okay, so when I mean looping, okay, or iteration, it simply means you designing a program that you writing a code that will kind of, that will allow you to run through every single item in a list. Okay, it could be a number, it could be an item. You run through that item and then you produce an output, and that is what iteration is all about. So I'll still cite a very good example with our list. For instance, I have a list, maybe name of people, maybe name in a list, maybe Jonah. I have Juliet. I have Simon. Sorry, it should be in quotes. Simon. I have Deborah. I have Michael. Sorry. Michael. Then I have Jude. Okay, now I have Jude. Okay, so this is a good example of a list. Okay, a very good example of a list, a Python list, but in this case containing names. Now I'm going to use this. This is going to be names. Okay, because in plural there are many names on that list, so I'm going to use names. Now in iteration, I can actually print out every single item on this list. Every single item in the list can be printed out, and I can use a for loop to iterate through that list. Normally, if I want to print the list, I can just hit my print statement, use my print function to say print names. Okay, that's the first process, print names. It's going to give me the entire list. But this is not what I want. I want every single item to be printed in an organized manner. And to do this, I need to use an iteration method or iteration function or tool or keyword. And the one I'm going to be using today is the for loop. Okay, so I can say for name singular. Okay, every single name is going to be looking at these names one after the other. So for name, every single name in that list. What's the name of my list? Names is the name of my list. Names is the name of my list. For name in names. Okay. Print name. Okay, print name. Now I'm actually asking the Python program to print every single name one after the other in that list, names. The name of the list is names, and for name if I don't want to use name, I can use item. Okay, I can use item. Okay, so I can use item in names, print the item. Okay, so I'll just run this program. Okay, good. So now I'm having these names printed out in a very organized format. Now what is happening here is that we said iteration. What happened is that with the for loop you have here, it goes back to the lists and considers Jonah. Okay, prints out Jonah, then goes back to the list again, the first item, then it goes back again to the next item in that list, which is Juliet, prints it out, and then goes back to the list again to the third item on that list, prints it and goes back again. It continues that way. It keeps looping until it gets to the last item on that list. Okay, it keeps looping until it gets to the last item on the list. So that is what happens here. That is iteration. Okay, item iteration. So now that is just the basic thing. Good. So now we can use numbers as well. We can use numbers to do that, to iterate. I can easily change this to numbers. I can easily change this to numbers. I can say 2, 3, 4, 5, 6, 7, 8, 9. Okay, sorry. I can say 1, 2, 3, 4, 5, 6. Okay, 6, 7, 8, 9. Okay, I can still iterate. What I changed here are just the items. I didn't affect, and nothing was changed in the program, so the program remains the same. So for item in names, okay, but in this case I can still change my variable name, but I want to leave it this way. For item in names, print item. It's going to give me these numbers, and these numbers arranged in a very organized manner. As you can see, numbers arranged from 1 to 9. You know, arranged in the order in which this item appeared on the list. So it goes to the first item, after that it goes to the next, goes to the next, goes to the next, continues that way until it hits the last item on the list. Okay, so it gives us a list of all the items we have right there, okay, in our lists. Okay, all the items. Good. So another thing we need to briefly look at, I'm just bringing a few things about the lists. Another thing we need to look at on the list, we have what we call the range function, the range function. So the range function actually helps us to kind of create a list without punching them in one after the other. Okay, so you can simply say you can still use the for loop for numbers. Let me say for numbers, for num in numbers. Okay, for num in, okay, let me say for num in range, in the range of these numbers. Then I'm going to specify a range 1. Let me say I want to take numbers between 1 and 50. 1 comma, I'm going to take 51. 1 comma 51. I explained something towards the last time when we were talking about the index formation in the Python list, and I said it goes from 0 to the last number formation, excluding the last option. So now I just say for numbers in range 1 comma 51, it's supposed to give me, I expect this to give me numbers between 1 to 50. So I don't have to type this in, but it's not going to give me 51. It's not going to include the last number here. So this, I'm making reference to the index here. It's not going to give me the last number. So I'm going to print number. Okay, print number. So I should expect numbers from 1 to 50 to be printed out. Okay, good. So now you can see our list here. In our execution box, you can see it's going from 1 here. It's going from 1, 2, 3, 4. If you keep going down, 1, 2, 3, 4. If you keep going down, 10, 11, and the rest of them, it will go till we get to 50. Okay, 50 is the last number there. Okay, and this is we actually use our range function. We can apply a lot of things using this range function. Good. We can find the average of numbers, of the numbers in this collection. We can find the average. We can find the average of numbers in this collection. For instance, you can say for norm in range this. Okay. For norm in range, just calculates. Okay. Calculates. You can say length. Okay, sorry, you can say average. Average, since we are looking for the average, let's use, it's better to use the average. Average is equals to sum. Okay, sum of numbers. Sum of numbers. Okay, sum of numbers divided by length of numbers. Okay, sum of numbers divided by length of numbers. Then you say print average. Print average. Okay, AVR. We have to print AVR. Okay, it's giving me. So it's telling me that type error, int object is not iterable. Okay, int object is not iterable. Okay, it simply tells me that this recognizes just the first number. Okay, the first number. That means it's an iteration. It recognizes just a very single number in this whole list. Okay, it's telling me that int object is not iterable. So we can only apply this if we have a whole list collection like we did before. Okay, a whole list collection. So if we have that number from, if we have a named list, maybe we have from 1 to 50 in that particular list, in that collection, we can actually apply this. But in this case now, we say for norm in range. So norm makes reference to each of the single numbers in this range. So we're saying sum in parentheses norm. Norm makes reference to every single number. It doesn't make reference to all the entire list. We cannot apply this here because there is no name given to this entire list. Okay, good. So unless we have it in an enclosed bracket, then in an enclosed square bracket as a list, then we can actually make reference to that to get the average of this whole number. So that's just the basic thing, but I believe we have cited a good example with that initially before this time of how we can actually get average with all this number. So that's just the basic thing about the list. And I believe with this we have actually looked at every necessary things and details we need to, all that we need to know about the list. I believe we have looked at all that we need to know about the list. So we have looked at the input and outputs. I think we looked at the input and output statement, how we can actually design a program where your users can impute a statement into your list and then it calculates and gives you an outcome. We have looked at the len keyword, the average, we have looked at also this evening, we have looked at the arithmetic operators, Python operators. We've looked at the addition, subtraction, multiplication operators, and the division, the exponentiation operators as well. We have looked at that. And the modulus operators. We have looked at the modulus operators and the assignment operator, and also the equality sign operators. We have looked at that. So before we wrap up our lesson this evening, I will quickly look at a lesson the last topic this evening on this, which is going to be our Python dictionary. Okay, so this brings us to the topic Python dictionary. So quickly I'm going to look at that. I'm going to treat the Python dictionary. Python dictionary. Okay, so the Python dictionary is actually a collection of pairs, keys and value pairs. Collection of key and value pairs. That's the Python dictionary. Okay, this is a collection of keys and value pairs. Okay, good. So that's just what it is. For instance, you go to, for instance, you want to make an analysis for a supermarket or a shopping center, and they're asking you to tell them the number of items in a place, maybe in a supermarket or something, and then you go there and you want to know the number of oranges you have there. You can just have the name of that item can be the key, and the values can be the number of orange you have. Maybe you have orange and then you say you have 10 orange. So a very good example of the dictionary, the Python dictionary, you have example, you can say item equals to, the Python dictionary is always enclosed in a curly bracket. It's enclosed in a curly bracket, and the items inside the Python dictionary could either be string items, or they can be integers. So now for instance, you are trying to check out the key and the value pairs in a supermarket, and then you are asked to tell them, okay, you have orange, you want to know the number of orange in this supermarket. You can just write that down, orange. Okay, orange. Use a column to separate the keys and the value. Okay, the orange is there, so the next thing you're going to write after the column is going to be the value, the number of orange you have. Maybe you have 20 oranges in that supermarket. Then after that, they are asking you to check the number of phones, maybe a number of phones in that supermarket. So you have phones. Maybe after counting, you discovered you had 7 phones. Okay, so, and also you have maybe in the supermarket you also have laptops, and they're asking you to check the number of laptops you have in the supermarket. Maybe after counting, you discovered you had about 12 laptops there. Then also maybe you have something else, shoes. Okay, you have shoes, and after counting the shoes you have in the supermarket, you discover that they were about maybe 35 shoes you counted. Okay, so this is a very good example of a Python dictionary. Now, what are the features? The features is just similar to a list, and this is another data type that we have in Python, and it's similar to a list, but the only thing is that we have pair of items, and these items are mapped to each other. They are mapped. That's mapping. Mapped in the sense that they are connected. Okay, so the first item before the item before the column, or the first item you're seeing in that pair, is called the key. Okay, so the orange here is the key, and the 20 there is the value. Okay, the phones here is the key, and the 7 there is the value. The laptops there you're saying is the key, and then the 12 is the value. Same thing applies to the other one. Shoes is the key, and the 35 is the value. Now, if you want to get the number of whatever you have, maybe if you want to get the number of orange, you can actually use the key to get the number. For instance, if I said item okay, dot get, okay, get in brackets, okay, I'll say orange. Okay, item dot get orange. So sorry. Okay, item dot get. Okay, then you write the key, which is the orange. Okay, I'll just go ahead and print my item. Print item. Okay, so print item. Okay, this is giving me the entire list, so I'll just use a variable to specify this so I can give it a name and print it. I can just say find equals to this as a print find, so I can have my value. Okay, so find. So using find now, I'm getting my value, and my value is 20. Okay, so 20 is my value, and I simply use the key. Okay, the key, just like you have the key to your house and you have so many items inside your house, and you cannot access those items without the key. You must open the door to your house, go in before you can access the item. Same thing happens here. You must have the key to be able to access all the items you have there. Okay, so let's see also, I believe we can apply the loop. We should be able to apply the loop here. Okay, we can make reference to the loop. You can say for items in for, okay, let's say for key in items. Okay, print key. For key in items, print key. So I'm going to hit the print and see what happens. Okay, so this is giving me all the keys in that particular dictionary. All the keys in my particular dictionaries are being printed out. Okay, now let me use this key and value. Okay, so I just run this. So it's telling me, okay, for key value in items, okay, it's telling me, okay, there's a trace back here for key value in items, value error, too many values to unpack, expected to, okay, expected to. So you have value there, and I'm hitting on that, and it's telling me, okay, you must have this, so you can just have just one. It's telling you that expected to, that's too many values to unpack, too many values. So we can actually take this out and still have the same thing. So obviously we can just print only the values expected, which is orange, phones, laptop, and shoes. That's what we can print. Okay, we can print all that, and in doing this we just use our for loop, and it's actually an iteration. So it simply goes back through, it goes through the dictionary and then gives us all the keys to the dictionary. Okay, that's what happens here. So obviously the for loop also applies to the dictionary. With the for loop you should be able to conveniently print out all the items, the keys in the for loop. Okay, so this is just the basic thing about the dictionary. And the dictionary, in the dictionary you can also add items in the dictionary. Okay, you can add items. For instance, you can say you can seek for items that are not in the dictionary by still using the get keyword. You can say item dot get. Okay, so in brackets I'm going to have a keyword, my keyword. Maybe I want to introduce a new keyword. Call it tip, for instance. Okay, tip. Okay, I say item tip. Sorry, it should be in quotes. Then I have tip. Then I have my column. I will just give this 0. Okay, item.get. Well, obviously this item is not right there on the list. Okay, it's not there on the list. I'm going to give it a variable name, and I'm going to give a variable name to that. I think I should expect an error here. So, and I say print find. Okay, so it's going to give me a traceback. Find.get, invalid syntax. Okay, good. So now simply going to enclose this. I'm going to enclose that because since it's a dictionary, I should have it in a curly bracket. So I'll just go ahead and print that again. See what happened. It said type error on hashable. Okay, type dictionary. Okay, on hashable. That means we cannot add that to the list. Okay, so but we can use the get keyword to get any of the items we want right there in the list. Okay, for instance, you want to get your phone, you can actually get your phone using the get keyword. Using the get keyword, you can get your phone. Good. Okay, it's telling you none. Yeah, it's telling you none because the spelling of phone here is not the same as this. It is, you have to make the correction by adding one more s and then go back and print again. Yes, it's telling us now that our phone is 7. So with the get keyword, you can actually get any of the items and the value of the items. Okay, so I'm using my phone, I'm looking for my phone. How many phones do I have? It's telling me you have 7. How many shoes? I can also get 35. If my shoe was here, I should have 35. So that is just the basic thing about the Python dictionary. So this will be applied as we progress. Okay, as we progress in our programming journey. So before we wrap up this evening, briefly, I'll just talk about conversion before we wrap up. Okay, type conversion. Okay, so before we wrap up this evening, I'm going to talk about type conversion. Now, let me say that I want to say that if you have z equals to in quotes 6, okay, in quotes 6. Now this 6 will not be recognized as a number, it will be recognized as a text. Now if I try to find the type, if I said I can say var equals to type. If I want to know the type of z, type in brackets z, it's going to tell me that the 6 there is a string, and you know that a string is a text, so it's going to tell me that the 6 is a string. It is not, it will tell me that the 6 is not a number. Okay, if I print that now, I'm going to see class string. Okay, class string. So that's what we have here. So it's telling me that this is actually a string. Okay, so if I want to do a conversion to this, I can put an int outside, then I will enclose that in the brackets. Okay, I enclose that in the brackets. then I'll still go ahead and run my program. Okay, it's giving me an error, and it's saying that okay, int argument must be a string, a byte-like object, or a number, not type. Okay, so now we're looking at conversions now. So I can actually have my, for instance, I can have an example, z equals to being equals to z being equals to 6. Okay, z being equals to 6. Okay, now I can also have my y being equals to 4.8. okay, 4.8. So now obviously my z here is actually an integer and my y is a float. Okay, my z is an integer, my y is a float. Okay, so in doing our conversion, most times we do our conversion when we are actually taking inputs. Okay, when we are taking inputs, most times we do our conversions. Okay, so now for instance, you want to say okay, div equals to z divided by y. Okay, then you print your div. Print your div. It's going to give you a floating point number. Okay, now if you are trying to convert this to an integer by introducing an int and then putting everything there in brackets. Okay, and let's see what the outcome is going to be. It's going to give you 1. Okay, but let me take this off again and let's see what the outcome was. Let's see what the outcome was. Give us 1 point. We have 1.25. Okay, we had 1.25.